A good day to you, learners. Hope you're doing fine. It's been a while since we uploaded a video, but here we are with a new video and a new lecture about binary operations and elective maths for our SHS 1 students. So today we're going to discuss binary operations as elective maths, brought to you by Jenna Evans Home Tuition. I'm your tutor. I'm Jeff. Okay, so let's dive into today's lesson. So binary operations. So what is it? Okay, so let's use an operation. You can use any operation, but we are using star in this tutorial or this lesson. So a binary operation star on a non-empty set R, that's real numbers. Okay, so of real numbers is a rule which combines any two numbers A and B belonging, so the symbol over there, it's belonging to R, okay, belongs to R to produce another number. So the simple operations in mathematics are addition, subtraction, division, multiplication, intersection, and union. Okay, so these operations are called binary operations because they combine two numbers to give another number. All right, hope this is clear. So let's jump into the properties of binary operations. So the first one, we have closure, we have commutative operations, we have associative operations, and then we have distributive operations. Okay, so let's look at a closure. What is closure? Okay, so let's say something about it. So closure, if A star B produces a number which belongs to the set R for all A, B belonging to R, then we say the set R is closed under the operation. Let's give an example to explain this definition. So, example, the operation star is defined on a set S, that is, it's bracket A, B, C, by the table below. So that's the table. So you have to determine whether or not S is closed under the operation star. Okay, now from the table you could see that a set S is closed with respect to the operation star if and only if any two elements in S, when combined, will result in an element in set S. Okay, so from the table it is clear that whenever any two elements in S are combined under star, the result is an element in S. So just take note. Just look at A star B. A star B. And the resulting answer is B, right? So it belongs to the element in S, right? Take a look at B star C. B star C. We have the element A, which belongs to the set S. Then we have C star C, which is B. Okay, C star C, the answer there is B, which also belongs to the element, the set S. Okay, so the point we are trying to make is if a number or a letter operates on another letter, produces an element in a set given to you, then it's closed, right? So you can see that hence the set S is closed to the respect of the operation star. Okay, so I guess this is okay for you. If you're not getting it, please pause the video, go back, reverse it, and listen to it again or follow through. Okay, so let's move on to the next one, commutative operations. Commutative. So a binary operation star defined on set R of real numbers is commutative if A star B is equal to B star A. So the opposite of it. So for all A, B belonging to R, the symbol there is belonging to R. Okay, good. Let's take one example. But for commutative, addition and multiplication of real numbers are commutative. But note, subtraction and division of real numbers are not commutative. Since addition and division, so let's take A minus B won't be B minus A. Are you getting it? And A divided by B won't be B divided by A. Just take a look at this. That is 2 minus 3. That's negative 1. But 3 minus 2, that's 1. So subtraction and division doesn't fall under commutative, but addition and multiplication falls under commutative. So let's look at this example. The operation star is defined on the set S, A, B, C by the table below. So you have to determine whether or not S is commutative. Whether or not S is commutative. So let's look at it. Now from the table, you could see A star B it's equal to B star A, and the answer is B. So just look at it. A star B gives us B, and B star A gives us what? B. Just check from your table. A on your left star the B at the top gives us B from the table. Then B from your left star the A up there gives us B. Yes. Same applies to B star C is equal to C star B, which is A, right? Good. Which is A. You're following. Good. Then A star C is equal to C star A. And what's the answer there? The answer is C, right? Yes. So hence the operation star is commutative, since for any two elements, that's X, Y, belonging to S, that is X star Y is equal to Y star X, A star B, B star A. Okay, good. Now let's look at this second example. The operation star is defined on a set of real numbers R by A star B. It's equal to A plus B plus AB. So that's the condition you are going to work with. Okay, A star B is equal to A plus B plus AB. Now you have to find I 3 star 4, I 4 star 5, then I 1 on 4 star 3 on 4. Then you have to show that the star, as the operation star, is commutative. Okay, so following the definition of the operation, that's the definition up there. So you are going to work with this. A star B, it's equal to A plus B plus AB. So you are going to work with this throughout. Okay, so please don't forget this. Okay, so our A star B, for the first one, we have to find 3 star 4. 3 star 4. So our first, the 3 becomes our A, represent the 3 by the A. Then the 4 becomes your B. Do you get it? So 3 star 4 now becomes the A star B. Okay, so substituting 3 star 4 into A star B, we have A, that is 3 plus the next one B, that's 4 plus AB. So that's 3 times 4. So 3 plus 4, we have 7. then 3 times 4, we have 12. So that will be 7 plus 12, that is 19. So that's for the first one. Now let's look at the second one, 4 star 5. So now our A is 4, our B is 5. Let's substitute it into the definition over there. So A, that's 4, plus B, that's 5, plus AB, that's 4 times 5. So we have 4 plus 5, that's 9, plus 4 times 5, we have 20. So 9 plus 20, that's 29. Okay, that's also for the second answer. Now let's look at the third one. 1 on 4 star 3 on 4. 1 on 4 star 3 on 4. Okay, so still using the same condition, A star B is equal to A plus B plus AB. 1 on 4 becomes our A, 3 on 4 becomes our B. Okay, so let's substitute it. So we have A 1 on 4 plus B 3 on 4 plus AB, that's 1 on 4 multiplying 3 on 4. Okay, so that's what we have on your screen. So 1 on 4 plus 3 on 4 gives us 1. Then plus 1 on 4 multiplying 3 on 4 gives us 3 over 16. 3 on 16. So our answer now becomes 1 whole number 3 on 16. 1 whole number 3 on 16. Good. Now we have to show that the operation star is commutative. The operation star is commutative. Now the operation star is commutative if A star B is equal to B star A. That's from what we said earlier on. For all A, B belonging to R. Okay, right. Now our first equation becomes A star B, it's equal to A plus B plus AB. That's from the question given, so that's it. And B star A, we said A star B is equal to B star A, so the next equation becomes B star A. So B star A, now we are to just reverse it, so we have B plus A plus BA. Okay, do you get it? Good. Okay, so we could see that A star B giving us A plus B plus AB, and B star A giving us B plus A plus BA is same. It's the same thing, right? Yeah, it's just that we've turned it. So since addition and multiplication of real numbers are both commutative, you could see that from equation 1 and 2, yes, it's obvious A star B is equal to B star A. So therefore, the operation is commutative. Good. Now let's move to our next operation. That is associative. Right. So with associative, a closed binary operation star defined on a set R of real numbers is associative if, now please pay attention to the condition here, if A star B in bracket star C, it's equal to A star into bracket B star C. Okay, so the first one in bracket, then on the right hand side the second one in a bracket. Okay, for all A, B and C belonging to R. So let's give ourselves this example. Example, we have AB into bracket multiplying C gives us A, that's outside, into bracket B and C. B times C, okay? And A plus B into bracket plus C giving us A outside plus into bracket B plus C. Okay, so we are just making this, the first one in the bracket, the second one outside in the bracket. Okay, so we can see that with associative, addition and multiplication of real numbers falls under associative. Please kindly note the signs, okay? The simple operations in mathematics. Addition and multiplication falls under associative. So let's take this first illustrative example. This first illustrative example. The operation star is defined over the set of real numbers, that's R, by A star B, it's equal to A plus B plus AB. Please kindly note or pay attention to the condition or the definition given here. A star B is equal to A plus B plus AB. Now, you have to find I 3 star into bracket 4 star 1, I into bracket 2 star 4, then outside the bracket star 5. Then you have to show that the operation star is associative. Okay, so let's dive in. Let's start with the first one, I. Good. So following the definition given from the question, A star B is equal to A plus B plus AB. Our first one, we have 3 star into bracket 4 star 1, and the answer becomes, now to be able to do this, we need to first solve the one in the bracket first, the operation in the bracket first. So we have 4 star 1. So our concentration will be on 4 star 1. That's why it's in red. Okay, so the first thing to do is solve the bracket first. So our 4 is our A, and the 1 it's our what? B. So substituted into the definition given, we have A, that is 4, plus B, that's 1, plus AB, that's 4 times 1. And the answer will be 4 plus 1, that will be 5. 4 times 1, that will be 4. So 5 plus 4, that will be 9. Okay, so that's why it's still in red. So now our new equation now becomes 3. The 3 we left to solve the bracket first, star the answer we had for the bracket, that's the 4 star 1. Now our 4 star 1 is 9. Okay, please, do you get it? Yes. Yeah. So the next equation now becomes 3 star 9. 3 star 9. We had the 9 from the bracket because we solved the bracket first. That's 4 star 1. Okay, so now we have 3 star 9. So our A becomes our 3, and our B becomes our 9. So substituting it into the substituting it into the definition, A star B is equal to A plus B plus AB. We have our A, 3, plus B, that's our 9, plus our A, that is 3 times 9. Okay, so 3 plus 9 we have 12, and 3 times 9 we have 27. So 12 plus 27 we have 39. So there's the first answer to our first question. 3 star into bracket 4 star 1. Good. Now let's move to our next solution. 2 star 4 into bracket, then outside of it we have star 5. So we said solve the bracket first, right? Okay, so 2 star 4. Now our 2 becomes our A, our 4 becomes our B. So just put it into the first definition given up there. A star B is equal to A plus B plus AB. So our A is 2, so 2 plus B is 4 plus AB, that's 2 times 4. Then you bring your star 5 out. Okay, so 2 plus 4, that will be 6. 2, 4, 8, right? Okay, so 6 plus 8, we have 14. So the answer to 2 star 4 is 14. So our next equation now becomes 14 star 5. 14 star 5. So 14 is now A. B is now 5, right? So into the first definition, we have A 14 plus B 5 plus AB, that's 14 times 5. And this is our answer. 14 plus 5, we have 19. And 14 times 5, that's 70. So 19 plus 70 is 89. Good. Let's move to our last one. We are to show that operation star is associative. So the operation star is associative if there's a condition A star B into bracket star out of A star C is equal to A out star into bracket B star C for all A, B, C belonging to R. Now A star B into bracket, right? Okay, then outside star C, it's equal to putting that into the equation given earlier on, A plus B plus AB. So we have A plus B plus AB representing the A star B. You get it? Then outside of it we have C. So here we have bracket first. Okay, so this is trying to tell you solve the one in the bracket what first. Good. Okay, so in expanding, we have A plus B plus AB plus C plus A plus B plus AB multiplying C. And rearranging it or expanding to get our first equation, we have A plus B plus C plus AB plus AC plus BC plus ABC. Okay, so that's the first one. Good. Also, A star A outside into bracket B star C gives us A outside into bracket B plus C plus BC. This time is B star C. So we are not seeing A plus B plus AB. No. It's now B plus C plus BC. Please, do you get it? Yes. So same thing, solve the bracket first. So this is what we have. We have A plus into bracket B plus C plus BC plus A multiplying into brackets B plus C plus BC. And upon expansion, to get our second equation, we have A plus B plus C plus AB plus AC plus BC plus ABC. That becomes our second equation. So from your comparison, we could see that from 1 and 2, that's the equations, it can be seen that A star B into bracket star outside C is same as A star outside into brackets B star C. Can kindly check. Yes, it's the same, right? Good. So we say therefore the operation is associative. The operation is associative. All right, let's move on to our next operation. That's distributive operation. Distributive operation. Okay, so if 2 into bracket 3 plus 4 upon expansion using the distributive property, you multiply. So that will be 2 times 3 plus 2 times 4. You get the same answer, right? Good. This is distributive operation. So in fact, if A, B, and C are real numbers, then A multiplying B plus C, it's equal to AB plus AC. And B plus C into bracket multiplying A will be equal to BA plus CA. We can therefore say that multiplication is distributive over addition. So when two closed binary operations stand, a triangle defined on a set of real numbers R are such that A star into bracket B triangle C, it's equal to into bracket A star B into bracket triangle into another bracket A star C for all A, B, C belonging to R. We say that the operation is left distributive over the operation. So we can therefore say that multiplication, same thing, distributive over addition. Let's look at this example. Okay, so the operation star is defined by A star B, which is equal to half AB. I don't know why it's not picking. Okay, so the two question marks over there is AB. Okay, A star B is equal to half AB, right? So if A is equal to 4, B is equal to 6, and C is equal to 8, evaluate I, A star into bracket B plus C, A star B, all in bracket, plus A star C, all in bracket. Then our last question, what conclusion can you draw about the operation star from your answer in BI and BII? Good. Okay, so we're given A to be 4, B to be 6, C to be 8. Let's start with our solution. So the first question is asking us to find A star B plus C all in bracket. And our A from the question is 4. Our B is 6. Our C is 8. So just substitute it into the definition given. So this is what you have. Okay. So for 6 plus 8, always bracket first, okay? So 6 plus 8 gives us 14. So we have 4 star 14. So we can now work it out, right? So our equation was A star B is equal to half AB. So we to get half into brackets, our A is 4 and our B is 14. So half 4 times 14. So half of 4 times 14, and the answer is 28. Our answer is 28. Good. Let's look at the second one. We're given A star B all in brackets plus A star C all in bracket. Okay, so let's just substitute the numbers into it. So A star B, that's 4 star 6 plus A star C, that is 4 star 8, right? Good. Okay, so this is what we get. All right. So substituting it, our A over there, that's 4 star 6, that's 4 times 16, right? Sorry, not 16, 6. So 4 times 6, then just put it into the definition. A star B half AB. So half AB, that's 4 times 6. Then half of the next one too, that's 4 times 8. So that'll be 12 plus 16. And the answer is 28. Simple. Good. All right. So what conclusion can we draw from it? So since 4 star into bracket 6 plus 8 is equal to 4 star 6 plus 4 star 8 from BI and BII above, it follows that the operation is distributive over the operation addition. Right. Good. Now, let's look at the next one. Identity or neutral element. Identity or neutral element. So as we progress, we'll be adding this and inverse, okay? So let's look at identity. So with the identity element, if E represents E with the identity element, okay? Represent E as the identity element. So if E belongs to R with the identity or neutral element under a binary operation star on a set R of real numbers, then the equation now becomes A star E is equal to E star A, which is A, right? Yeah, for A belonging to real numbers. That is when we combine any number with identity element under a given operation, we get a number. I repeat, when we combine any number with identity element under a given operation, we get the number. The identity element E is unique. That is, we have only one identity element under each operation. We have only one. Okay, let's take this illustrative example. The operation star is defined over the set R of real numbers by A star B. It's equal to A plus B plus AB. So we have to find the identity element under the operation star. Okay, so let's work it out. So the first thing to do is let E belonging to R, okay, belongs to R, be the identity element under the operation star. Okay, let E belonging to R. So I told you represent E as the identity element. Okay, so then our equation from the question, we said A star B is equal to A plus B plus AB. So we have to represent it by the identity element. So we have A star E. A star E, it's equal to E star A, okay, which gives us A. We said when we combine any number with identity element under a given operation, we get the number. So the letter here is A. We are combining it with the identity element. So what do you think we'll get? We'll get the letter A. So that's the first one. So A star E is equal to E star A. Is equal to A. Right. Good. But A star E, from the question, when we substitute it into it, we will get A plus E plus AE. The first, from the question, it says A star B is equal to A plus B plus AB. So we are just putting it into the definition. So A star E becomes A plus E, not B, okay? So A star E plus AE, which is equal to what? A. So solving for E, we have A plus E plus AE giving us A. So let's group. So move the A on your left hand side to the right hand side. So our equation becomes E plus AE, it's equal to A minus A, right? Good. Let's factor the E out. Sorry, that E is a small, it's in lowercase, okay? Not uppercase, lowercase. So when we factor the E out, so we'll have 1 plus A. A minus A is equal to 0. So there's the equation. So we are to make E the subject. Make E the subject. So we divide by 1 plus A by both sides. Okay. So our E becomes 0 over, or 0 on 1 plus A. Now 0 over any number is 0, right? 0 over 5 is 0. So the answer here is 0. So E is 0. So E is equal to 0 is the identity element under the operation star. Whew. That's very nice, right? Good. Okay, that's just one example. Okay, so let's look at the inverse elements. Inverse elements. Inverse elements. Right. What is inverse? An element A inverse. So A exponent -1. We say A inverse, right? Good. Belonging to R, or belongs to R, is called the inverse of A belonging to R under the operation star if A star A inverse is equal to A inverse. Star A is equal to the identity element. So that is when we combine any number and its inverse, we obtain the identity element. When we combine any number and its inverse, we obtain the identity element. So identity element and inverse, they move hand in hand. Okay, so let's explain further with this question. Let's explain further. An operation star is defined on a set R of real numbers by A star B is equal to A plus B minus AB, where A, B belongs to R. Okay, now you have to calculate A. Calculate 8 star -4 and -4 star 8. So two questions in just in one question. Okay, B, find the identity element of E of R under operation star. Determine the inverse under star of a general element A belonging to R, and state which element of R has no inverse. Then you have to find the inverse of 2. Find the inverse of 2. Wow, okay, fine. Let's look at the solution. So with the first one, the condition given was A star B, it's equal to A plus B minus AB. So we are going to use this in our solution. So the first one, we have to calculate 8 star -4. So 8 star -4, 8 becomes our A, and the B is -4, right? So we have 8 plus the B minus 4, then minus AB. So that would be minus 8 times -4. 8 times -4. So we have 8 plus -4, that, so the negative always suppresses the positive. So we have 8 minus 4 plus 8 times 4, which gives us 32. But we have minus minus, okay? Negative 8, negative 4. So that gives us plus 32. Okay, so our resulting answer will be 36. 36. Now let's do that for the other one. We have minus 4 star 8. Minus 4 star 8. So here we our minus 4 is our A and 8 is our B. So we have substituting it into the equation. We have minus 4, that's our A, plus 8, that's our B, minus AB. So minus into bracket negative 4 times 8. So minus 4 plus 8, then 4 times 8, we have 32. But minus minus gives us positive. Same answer, 36. Okay. Now, let's move on to the B aspect of the question. We have to find the identity element E of R under the operation star. Okay, so since E belongs to R, is the identity element for any element A belonging to R, A star E is E star A is equal to A, right? Do you remember? We said any number combined with the identity element gives us that number, okay? So A star E is equal to E star A is equal to A. But A star E, from the definition given, A plus B minus AB, let's substitute it. We have A plus E. This time we are saying A star E, so not A star B. So A star E is equal to A plus E minus AE. Okay, I hope you are getting it. Good. So let's move the A on our left hand side to the right hand side to go and subtract. So we have E minus AE is equal to A minus A. Good. So when we factor the E out, we have E into bracket 1 minus A, which is equal to 0. A minus A is 0. Okay, so we want to make E the subject, so we divide by 1 minus A. So E is equal to 0 over or on 1 minus A, and the answer is 0. So therefore the identity element E is 0. That's cool. Okay, this brings us to our next question. We have to determine the inverse. That's the C part. Determine the inverse under the operation star of a general element A belonging to R, and state which element of R has no inverse. Find the inverse of 2. Good. So the first thing to do is to let A inverse belonging to R be the inverse of A belonging to R under the operation star. Then we'll have A star A inverse gives us A inverse star A, gives us the identity element. I hope you remember that. Okay. But A star A inverse is equal to, from the question, A star B is equal to A plus B minus AB. So A inverse will have A plus A inverse minus AA inverse. Okay, AA inverse, and that gives us the identity element. But from our solution in B, we had 0 for our identity element, so where E is equal to 0. Okay, so now this becomes our equation: A plus A inverse minus AA inverse is equal to 0. Okay, So A inverse minus AA inverse, it's equal to negative A. So move the A from your left hand side to the right hand side to, it becomes negative, right? So negative A. So let's factor the A inverse out. We'll get 1 minus A. A inverse into bracket 1 minus A. It's equal to negative A. Good. So A inverse, to get A inverse, we have to divide both sides by 1 minus A. So A inverse becomes negative A over or on 1 minus A. So this is the inverse of A belonging to R under star. Let me repeat the answer again. A inverse is equal to negative A on 1 minus A, and which is the inverse of A belonging to R under the operation star. Now, the inverse does not exist if the denominator of A inverse is 0. The inverse does not exist if the denominator of A inverse is 0. So that is, if 1 minus A is equal to 0 or A is equal to 1. Therefore, the element R does not have an inverse. Therefore, the element of R, that does not have an inverse is 1. Okay. So to find the inverse of 2, our last question says find the inverse of 2. So to find the inverse of 2, we have to substitute 2 into the expression for the answer we had. A inverse is equal to negative A over 1 minus A. So A now is it's negative 2, right, from the question. Yeah, so negative 2 over 1 minus 2, and that gives us negative 2 on negative 1. Cancel the negative out, and that is 2. So therefore, the inverse of 2 is 2. The inverse of 2 is 2. Wow. We've learned a lot today, right? It's time for you to try your hands on these questions, okay? So there's the first question. Please make sure you try your hands on them. Also, go back, watch the video again if you are not getting it, to get a smooth, nice work done. All right, so these are the questions. Please try your hands on them. I'll see you next time. Bye.